Hi, this video we're going to look at pulley. We see pulley quite often, right? You have a rope that's wrapped around this disc, and we want to look at the characteristic of pulley. So if you imagine this tension here is T1 and another end is T2, and we want to find out the relationship between them. So first we were thinking, if we just do moment equation, and where do we do moment about? How about we do moment about this point O? That is the center of this disk or this axle. And so in that situation, just be aware all those T1 and T2, they will be in tangent, right? Relationship with this the circle. So in that situation, you have a T1 times moment of arm. Since it's in tangent, you're going to, this is red line is going to be our moment of arm. That is the radius of the circle. And for this T1, rotating about O, that's counterclockwise, so that's positive. Now let's look at the T2. T2 then times moment of arm. Same thing, the moment of arm will be perpendicular to the force, and it's also tangent and also equal to radius of this axle. And this is going to be clockwise rotation, so it's going to be negative. So equal to 0. Then we cancel out the R here. Then what do we realize? T1 is equal to T2. And this is fundamental relationship for pulley. What this tells us is the tension in one rope, because this is one rope wrapped around, right? The tension in one rope stays the same. So that's a conclusion we have gotten for pulley. And with that relationship, it's easy to solve any pulley problem. For example, here you have in your WebWorks. And now let's take a look. There's a load of hook 0.8 kips is lifted with the rope hoist as shown, and find the force F rope. So now let's look at it. Let's trace it. If I trace around, this rope is wrapping around here, wrap around, whole thing. All right, you see what I'm trying to do? Basically, it shows this one rope is wrapping around the pulley. It's one rope. Knowing the relationship we had over here, the tension stays the same, then can I safely say if this is F rope we're trying to say to calculate, this is going to be the same, right? And because this is wrapped around this pulley, so that's F rope. This is the same thing you're solving. And since they're wrapped around this pulley, that will be the same. That's F rope as well. Now let's look at this. It's wrapping around this pulley H. In that situation, this is F rope as well. And then go around the pulley C, and that is F rope. So in other words, you get my point. Every single line here, tension is F rope. Now, knowing that F, we're going to look at the FBD of this session. Right? So in this section, you have 3 pulleys. And you have D, C, B. So B, C, D right here. Now let's think about it. Then you have line here. You have another line. You have another line here. So I'm copying those 3 lines. Then you also have another line here, wrap around C. You also have another line wrap around B. Right? And for all those, is going to be tension going up. How many of them? Let's count. 1, 2, 3, 4, 5, 6, 7. So there are 7 total, and they are equal. So it's a 7F rope going upwards. And any force going down? Yes, F hook. So some forces at y direction. We have 7F rope minus F hook equal to 0. If F hook for me is 0.8, then can you figure out F rope easily? It's just going to be 0.8 F hook kips divided by 7. And make sure you change that to pound force by times 1,000. Then you got your answer, right? So the beauty of solving any pulley problem is understand this rule. Tension in one rope stay the same. Now let's look at one more example. For this, they said that there's a F hook, 1.6 kilonewton, is lifted with rope hoist system as shown, and the angle is given. Determine the F rope. Again, knowing this is one entire rope, if you follow along, realize all this tension here should be stay the same, should be all equal to F rope. Now you just need to thinking about where do I draw the FBD? How about we draw the FBD of this entire thing? Okay, so if we do that, oops. All right, so that's going to be the subject you're looking at. Now let's look at the force. So you have these 2 tensions going up, they are equal. Then you have another tension come not straighten up like those 2, but they are coming at an angle, theta here. Same thing here, it's symmetric. There's another tension come as an angle theta as well. Then the whole thing have a downward force F hook as 1.6 kilonewton. So that's what we have here. And if this is going to be F rope, all those are F rope. That's just a different direction, but the magnitude is the same because the tension stay the same. Then how do we solve it? Of course, this is symmetric, and the forces at x is going to be equal to 0. And if you were trying to write this equation at forces x equal to 0, you won't get any productive solution. Let's try why. Why so? So for example, you have this F rope. X direction would be cosine theta because it's adjacent, that's positive. Then you have this F rope. It's pulling to the left and upward, so left is going to be negative, and it's also adjacent, so cosine theta equal to 0. Like I said, well, this one equation does not bear any fruit. It does not cannot solve anything. However, forces at y can get our answer. Now let's look at it. This F rope, y direction, is going up, so we have F rope times sine theta. Now let's look at F, this one, also going upward, it's F rope times sine theta, so that's basically 2. Then you have this 2 going straight upward, so it's F rope, and all together, it's going to equal this F hook. So knowing this, can we solve this F rope? So as F rope is going to be equal to F hook divided by 2 sine theta plus 2. Then that will give us the answer for this problem. All right, that's all for this pulley lesson, and I'll see you next time. Have fun. Bye.